can you plot the graph between translation in pure rolling condition? We are about to reach in rotational motion. As I have already told you, rolling motion, rolling motion involve what involve? First translation, and second one is rotation. Translation already discussed. Now we are going to discuss rotation. In order to cover rotation, again we are going to take a figure. Where is the figure? Let me search. In order to discuss pure rotation, we need circular disc. Here we have circular disc. Here we have circular disc. Now we are going to discuss rotation. Here is the center of the disc. Here is the center of the disc. Now it will rotate about the center O with angular velocity omega. Okay, and again we have certain points A, B and C on the circumference of the disc. If this disc is under pure rotation with angular velocity omega, then no doubt all particle on the circumference will also rotate. And radius of this circular disc is considered to be capital R. VA is equal to R into omega and VB is equal to R into omega, and again VC is equal to R into omega, and VD is equal to R into omega. In case of pure rolling condition, relation between the linear velocity and angular velocity is given by V is equal to R omega. Omega is the angular velocity, which is nothing but this rate of change of theta. This is nothing but it is rate of change of theta. Angular displacement. It is the rate of change of angular displacement. Okay. Now here's the relation between the linear velocity and the angular velocity. Here we have different points on the circumference of the disc. In order to find the pure rolling condition, what we have to combine these two motion. Obviously, combination of these two motion will give rolling, or we can say pure rolling motion. As we know that in case of translation, it has velocity v0, obviously, and at point B, v0, which we have discussed earlier, v0 or v, it's upon you what you have to write, whether v0, v under cm, center of mass velocity, and this is v0 and this is v0. Now check the angle between these two velocity. Velocity is a vector quantity. What we need to check? First we have to check the angle between at different points on the circumference of the disc. In case of pure rolling, it will cover both translation as well as rotation. Here is the angle theta, which is equal to 0, and here is the angle 90 degree. Here is the angle 180 degree, and in this case 90 degree. Now we get point of contact. Where is the point of contact? Disk and the point which is on the surface, which is point C. C is the point of contact. Okay, C is the point of contact. What is the angle between linear center of mass velocity and angular velocity, which is because of rotation? Vc is equal to r omega. Angle is 180 degree. What will the resultant velocity at point C? Obviously, it is v at C point, which can be written as v prime, which is v naught square, which is nothing but v naught square plus, first we have to erase, which is v naught minus r omega. But in case of pure rolling, v is equal to r omega, which is nothing but it is v naught minus v naught at the point of contact, but we get 0. Relative or resultant velocity at this point is 0. But in case of a point, here we get the third concept. This is called the no slip condition. At point C, we are getting resultant velocity 0, which is no slip condition, and most important condition for pure rolling condition. In order to be pure rolling, it is necessary to be in no slip condition. Disk must be in no slip condition, whether it is a disk, sphere or circular loop. It must be in no slip condition. That's why friction is indeed required at the point of contact, as shown in the figure. Here we get friction requirement of friction at this point. Why? In order to get this situation, no slip condition. Now what is next? Rest is nothing. It's quite easy now. It has been quite easy now because resultant velocity at point A, B and D. See, we have already discussed. It has been 0, which is no slip condition. And at point A, angle is 0 degree. Add all this. V naught plus r omega. It will be added. Why? Because angle is 0. Resultant will be twice of V naught. Okay. And at point D and B, angle is 90 degree. What will be the resultant velocity? Vb is equal to, let me first clear this. At point A, we get, at point A angle is 0. That's why V naught plus r omega. These two velocity will be added. First is because of translation, second one is because of pure rotation. Another one is Vd is equal to Vb. Both have angle 90 degree. As shown in the figure, angle is 90 degree. What will be? V naught square plus r omega whole square, which is angle between these two velocity, linear translation motion as well as the rotation. In case of D point and in case of D and B point is 90 degree. Is it 90 degree? 90 degree. Therefore, V naught square, it will be V naught square pure rolling involve translation as well as rotation. First we had covered translation. Now we are going to cover pure rotation. In order to cover pure rotation, we need to have a circular disc. Circular disc, it may be circular, it may be spherical. It's upon you which figure you have. Here is a circular disc. Now we will enlarge. What we have to take, first we have to take its center. Here is a center. Okay. Whenever it will rotate, with angular velocity omega, each particle on the circumference, A, B, C as well as D, it will rotate in the same sense. If it is clockwise, then all the particles on the circumference of the disk will be clockwise. For rotation, what is the relation between the linear and angular velocity? V is equal to R omega. In case of pure rotation, linear velocity and linear and angular velocity related by this relation. And at point A, VA is equal to R into omega, and VB is equal to R into omega, VC is equal to R into omega, and we have R into omega at D point. Here is the point of contact. Now what we have to do, this is the pure rotation. In case of pure rolling, involves translation as well as rotation. Now we combine these two motion. Translation motion along this, which is V naught. This is V naught. This is V naught, and this is V naught. Now angle between the translation as well as rotation. Angle is theta is equal to 0. Here theta is equal to 90 degree, as we are seeing that this is 90 degree and here is 90 degree. And what's about this? This is 180 degree. Okay. This is a point of contact. It will tell about why friction is required at the point of contact. First, we will find the resultant velocity at A, B, C, D. At A point, theta is 0. Obviously, VA prime, which is net velocity or resultant velocity, V naught plus R omega mod V naught and R omega. In case of pure rotation, V is equal to R omega. As we know that in case of pure rotation or pure rolling, we can write V naught is equal to R omega. It will be twice of V naught, or we can say twice of R omega. It's upon you what you write. In case of D and B, 90 degree, VD is equal to VB is equal to V naught square plus R omega square, which can be written as root 2 V naught. R omega is V naught. Okay. Now at point C, which is mod of V naught minus R omega, angle is 180 degree according to parallelogram law. Whenever two vectors are given, angle between these two vectors is given, we can write resultant velocity is under root of VA square plus VB square plus 2VA into VB cos theta. Theta is the angle between these two vectors, which can be written, theta is 180 degree. Then VC is equal to V naught minus R omega, which is 0 because R omega is V naught. So V naught minus, then V naught minus V naught is 0. Okay. Here we get the important condition for no slip. Pure rolling condition. No slip condition is required, obviously. No slip condition. Here we get the proof why friction is important in case of point of contact. This is the important condition, no slip condition. This is the no slip condition, most important condition in case of pure rolling. Okay, which is important, most important, and we can write V naught is equal to R omega only in case of pure rolling motion. Here we get the complete analysis of pure rolling motion, which is most important in case of JEE advance. Okay, and the number of relations have been derived here, which are used as a short tricks in case of another competitive examination. In further session, we will discuss rotational kinetic energy, translation kinetic energy. Now you have to tell me one thing. What is the relation between moment of inertia and angular velocity in case of pure rotational kinetic energy? Can you plot the graph between translation kinetic energy as well as rotational kinetic energy? What is the relation between these two? Let me know, then I will discuss it further. Okay, thank you.